Welcome to Lesson 5D, Average Income. In the previous assignment, you calculated the simple overall average salary of the 10 cities shown. It says to multiply the population of Phoenix times the average salary in Phoenix, and what does this answer represent? Go ahead and hit pause, write down a calculation, and then come back and we'll do it together. So the question asks us to multiply the population of Phoenix times the average salary in Phoenix. Population in Phoenix is 1,488,750 people. It is always good to have a unit. Times an average salary of $98,000 per year per person. They're asking us to multiply these together, so I'm going to try on my calculator. 1,488,750 times $98,000, and I'm getting this number. So it looks like 145,897,500,000. So it asks, what does the answer represent? And this is the total amount earned by everyone in that city. Here are the people. We can reduce people and per person. And this would be the total amount of money earned by all of the people, the cumulative amount for all the people. In this lesson, we're going to understand the meaning of expected value. We're also going to understand that an expected value is a weighted average. We'll be able to calculate expected value, and then we're going to make predictions about real-world scenarios based on our knowledge of averages, weighted averages, and expected values. So you've now had your first test, and I've mentioned that you should have some kind of glossary list or flashcards or sticky notes, because now we're starting more words like weighted average and expected value. So how are you going to learn this word, what it means, and a process associated with it? Make sure you get that started, and then on question number 2, hit pause and jot down how you or how would you calculate the weighted average of the salaries. So to calculate the weighted average of the salaries, we're going to have to replicate what we did in question 1. We would multiply the population by the average salary, get a large number. Let's go back and look at that. So to calculate the weighted average of all of these salaries, to give them the weighted average, we would multiply these together. We would multiply all of these together. And, well, you get the picture. Multiply all of these together, and then in the end, we would add all of these products together, and then we would, didn't mean for that to happen. Then we would divide by the total number of people. We would divide by 7 million, and that would give us a weighted average. So you're probably thinking there has to be a better way. Well, in this lesson, we are going to extend our discussion of weighted average by examining something that's called expected value. Again, make sure you've got your glossary or flashcards or something started where you are noting and going to memorize and learn all about expected value. Expected value is a weighted average. But we're going to work with percentages rather than the raw data like we were just looking at with all of the average salaries, with all of the population, with all 7 million of those pieces of data. We're not going to look at the raw data. We're going to look at percentages. We're going to determine a value's percentage of the total. That's something definitely to make note of. And then we're going to multiply that percentage by the variable of interest. The variable of interest. And in our first case, it's going to be salaries. So we're going to determine the percentage of the total population of whatever a city or whatever we're looking at is part of, and then we're going to multiply that percentage by the value of interest to calculate our expected value. Beginning question 3, actually before, it says let's apply these principles to compare the salaries and populations of the 10 cities that are listed. Open the spreadsheet that we calculated in preview assignment 5D, and we're going to look at this information, and we're going to work on a column, and we're going to create another column, and we're going to do a calculation, this expected value, much faster than what we could have done with all of that raw data. So I'm going to head on over to the spreadsheet and work probably the rest of our lesson from there. Question number 3 says, calculate the amount of money that each city contributes to the expected value of the overall average salary. Before I can get there, I need to get caught up to where you are from your preview. The first part of this, the percentage of the total population. So I'm going to hit equals. I'm going to say that I want to take what's in cell B2, and then it highlights it for me. And I want to divide that by, and actually I'm going to back, oh, that's not what I wanted. And then I'm going to divide it by the total. I don't even have the total on here, so let me get out of this, and let me go down here. Let me go to the total, and let me tell it equals. I want it to sum from B2 all the way down to B11. And that way it'll give me a sum of 7,304,155. Now I'm going to tell it that I want it to, I'm going to start, what was I doing? Yeah, I want to do equals, start a parenthesis, and I want B2 to be divided by B12, and I'm going to multiply that by 100. I'm going to hit return, and I get 20. Now, I don't have the answers that I'm looking at in our document are to the nearest hundredth. So I'm going to go back and reset that, and I'll come back to you in just a second. So now I'm back, and I went up into the tell me what you want to do, and I was telling it I wanted more decimal places, and all it did was show me increased decimal. And so I clicked increased decimal, and now I have it to the hundredths place. Another thing I did is I went back into the formula, and before I turned the recorder back on, I did the drop down to see if it was going to work, and it didn't work, and I had to go put in the $sign to make it only pick up B12 every time. Now that I have it where it's B2 divided by $12 to stick with that number only, and then multiply it times 100. I wanted my 2 decimal places. Now I can drag and I get all of the percentages. Another reminder, or a reminder, we are doing what's called expected value. And this is another form of weighted average. What I have found is the Phoenix population of this entire group's population, and it represents 20% of the entire group. So now we're about to apply this 20% to the salary so that the salary has 20% value of this entire list. It's not just lumped in as another of the 10 salaries or average salaries. So I have my percentages. The only thing I would like to do here is just to check and see if I'm at 100%. So I'm going to go ahead and do an equals and sum from C2 down to C11, and yay, it's exactly 100%. So on my percentage of my total population times average salary, I am now down to, or not, I'm just now getting to question 3. Calculate the amount of money that each city contributes to the expected value. We're trying to get right down here to the expected value, but to get there, we need to find out what each city's average salary is going to actually contribute. And in this case, it's going to contribute 20% of the 98%, and let's see what happens. I'm going to go ahead and click in that I want to multiply C2 times D2. And when I do, I get 1 million, and I can't go over where I'm starting. So it's not recognizing that I have a percentage. So I'm going to undo that one. I'm going to go back and say, okay, what it really meant is I want you to take my C2 and I want you to divide that by 100. Then I want you to multiply that times what I've got sitting over in D2, and that looks a little bit better. 19,000 is 20%, about 20% of what we're looking for. So once I'm convinced I have that one right, I'm going to go ahead and see if it's going to let me drag this down, and it's going to do all of the rest of the percentages for like 11% of 125 is 14. 8% of 101,000 is 8,000. So number 3 says calculate the amount of money that each city contributes to the expected value of the overall average salary. We're done with question 3. The question 4 says now find the total of the 10 cities, and this result is our expected value. So even to repeat to yourself, I found the population percentage, I multiplied that times the salary. I'm looking at all these numbers. Now I'm going to add them up. So I want to do equal sum, and I want to go all the way up here from E2 down to E11. When we do, we're looking at 94,000, and that is the expected value of the average salary of these 10 cities. So moving on to question 5. Describe the similarities and the differences between expected value and weighted average. Weighted average, you might remember we took all the population times 98,000, and then we were going to add that up to all the population of San Francisco times the average salary of San Francisco, and then add all of these up and divide them by 7 million, and we were going to get a number very, very close to, if not identical, to this expected value, just going at it a different route. Similarities, differences. I think what we just did on the expected value was much faster, especially with Excel. So let me read you a thought. The expected value and the weighted average produce the same value, the same number. Weighted averages are going to be found using the raw data, frequencies, and whereas the expected values are just using the percentages. Remember these over here? We were just using percentages. Without access to spreadsheets, the calculations of the weighted averages, those can be much more cumbersome than calculations of the expected value. This concludes our lesson 5D. Look at your calendar to see if you have any more lessons to do for this week's deadlines, and I'll see you at the next lesson.